Good day everyone, welcome back to our Math 9 synchronous class discussion. We are still in the second quarter, week 8, and we are using module number 8 entitled Division of Radical Expressions. In this module, we have the following objectives to attain. First objective is to use the basic properties of radicals to obtain an expression in simplest radical form using rationalization. And the second one is to perform division of radical expressions. We have only one lesson for this module, so we will discuss it little by little. Okay, lesson number 1 is focus on the division of radical expressions. What's in? We'll have a short quiz first before proceeding with our main topic on division of radical expressions. Try to simplify the following radical expressions. We have the following items: 1, 2, 3, 4, and 5. So, you still remember this one? On the previous modules? Addition, subtraction, multiplication, division, mga module 5 na siguro to. Radical expressions, simplifying radical expressions. With item number 1, for us to simplify this one, we have to factor 54 as 9 times 6. Why? Because 54 is not a perfect square, but it has factors that has a perfect square, which is 9, and 6 is not. Then x cubed can be factored out as x squared times x exponent 1, while y exponent 4 need not be factored out because the exponent itself is already divisible with the imaginary index 2. The square root of 9 is 3. Kawasan 3. X squared can be cancelled with the index 2. So 2 divided by 2 is 1. So gawas ng x. While y exponent 4 divided by index 2 is 2. Manang y squared. What remains inside the radical symbol is 6 and x exponent 1. Or pwede siya sa wato ng x, ang exponent nga 1 sa x. Pwede na siya square root of 6x. So you have there the final answer of number 1. How about number 2? The given is 2y square root of 8m, 6, and 5. So we copy 2y. We factor 8 by 4 times 2 since 8 has a factors of perfect squaring of 4 and it's not perfect square 2. Why perfect square? Because the index is imaginary 2. So square root. So perfect square. M's exponent 6 need not be factored out because 6 is divisible with the imaginary index 2. While n exponent 5 should be factored as n exponent 4 times n exponent 1 para ma-divide ang 4 nga to sa index 2 imaginary. Next is, okay, this is the final answer. Yung saan ipagkuha ang final answer? The square root of 4 is 2. Get times sa 2y, that is 4y. Next, m exponent 6, 6 divided by imaginary index 2. 6 divided by 2 is 3. Munang m cubed sa gawas. While n exponent 4, 4 divided by index 2 is 2. Munang n square. So what remains inside the radical symbol are the following: 2 ug ang n exponent 1 or 2n. So, pwede ra siya. Or kung imo siya i-arrange alphabetically, that is 4m cubed n square y square root of 2n. Okay? Number 3. The given is the square root of 49x4 over 25y exponent 6. So, nakikita na siya sa module 5, I guess. So, the square root of the fraction is equal to the square root of the numerator over the square root of the denominator. So, buwag. Next. The square root of 49 is 7. x4, 4 divided by imaginary index 2 is 2. Muna x squared. Square root of 25 is 5. Y exponent 6, 6 divided by imaginary index 2. 6 divided by 2 is 3. Munang y cubed. So, y na habilin sa radical symbol. So, our final answer there is 7x squared over 5y cubed. How about number 4? Same process with example number 3. the square root of the fraction 4 over 10 is equal to the square root of the numerator over the square root of the denominator. Square root over 4 over square root of 10. Square root of 4 kay 2, while the square root of 10 is none. 10 isn't a perfect square. The closest perfect square is 9. So therefore 10 is considered irrational. Even if you factor 10 by 5 times 2, none of its factors is a perfect square. So therefore 10 remains inside the radical symbol mo ng 2 over square root of 10. So makonsider nyo siya nga mo siya ang answer. But question, this is still not the final answer. So this needs to be simplified pag yun. So in what way? That will be taken up in this module. Okay, well, let us proceed first to example number 5. The cube root of 64, x exponent 6, y exponent 12. 64 is expressed as 4 cube y. Kaya tungod, question there, is 64 a perfect cube? Yes, it is. 4 cube is 64. Nga naman, nganong cube, perfect cube is 64 because our index is 3 man, cube root. So, is 64 a perfect cube? Yes, it is. 4 cube is 64. Okay, 4 times 4, 16. 16 times 4, 64. So therefore, 64 is a perfect cube. So ma-extracted na siya. X exponent 6, dili usbon because 6 is divisible when the index 3, as well as the exponent of y, which is 12. 12 divided by 3. Ma-divide na siya. So our final answer will be 4x squared y 4. Nga naman, ang exponents of 4, which is 3, makancel sa index 3. So, cancel, gawas ang 4. Exponents of x, 6. 6 divided by 3 is 2, muna x squared. Y, 12 divided by index 3 is 4, muna y exponent 4. So, y na habilin sa radical symbol. Everything goes out. So, of the 5 items, the only item that contains not final, ang iyang answer is item number 4, because if we will go back to the conditions of a simplified radical expression sa module 5, dito na to ma-recall, ma-check whether this answer of ours is really the final answer or not. Okay, so to move on, what's new? Based on the short quiz a while ago, let us try answering these questions. Which items you found easy to answer? Kamari makatubagan na from 1 to 5. Which item or items you found difficult to answer and simplify? What is it? In order to simplify item number 4 in the short quiz, we need to check the following conditions mentioned in module 5 of this quarter, which states that radicals are in its simplest form if and only if. So mga condition. First, there are no perfect nth factor remain in the radical. Katong ganina itong mga solutions sa examples 1 to 5. Halos, kung na yung maging habilin, dili siya perfect square, dili siya perfect cube, no? So, dapat, kung simplified siya, there are no perfect nth factor remain in the radical. Next, there are no radical or radicals in the denominator unless it is being rationalized. So, asa ato nga item from 1 to 5 na naay radical sa denominator? That is item number 4. Ang answer ato is 2 over square root of 10, wherein radical ang denominator. So, it needs to be rationalized. In order to solve item number 4, given that square root of 4 over 10, it would need a different law of radicals. Sorry, napanganog L. So this is the rule. The division of radicals. The nth root of a fraction, itong ganina, is equal to the nth root of the numerator over the nth root of its denominator. So the nth root of x over y is equal to the nth root of x over the nth root of y. Muna itong gigamit sa item 3 and item number 4. Such that y, it should not be equal to 0, and only when the radicals are similar. Pwede rin siya magamit kaninga concept if the radicals are similar. meaning para sa index. For this case, the square root of 4 over 10 is equal to the square root of 4 over the square root of 10. When simplified, have become 2 over the square root of 10, as seen on the solution at the start of this lesson, from which the denominator is a radical. With this, there is a need to rationalize the expression. There is a need to rationalize the expression of the given answer. So how is rationalization done? So what is the process of rationalization? So we have case number 1, when the denominator is a monomial. Case number 2, when the denominator is a binomial. They follow the same process, only that manalay difference gamay. Okay, for case number 1, rationalizing the denominator when the denominator is a monomial. Rationalization is a process of making a rational expression containing radical on the denominator, pareha tong 2 over square root of 10, into a rational number. Himuon ang denominator nga radical into a rational number or integer by multiplying a radical, both numerator and denominator. So sa i-multiply atong expression kaning 2 over the square root of 10 is mag-multiply og radical nga pariha ra pud siya sa more or less pariha siya sa denominator ng square root of 10. Both on the numerator and the denominator ang radical nga i-multiply. That makes the radicand on the denominator a perfect nth power. Through extraction, the denominator can be made into a rational one. So ang concept, x over the nth root of y is equal to, so sa process pag-rationalize, we copy the rational expression x over the nth root of y, multiplyan siya og same radical nga makita sa denominator which is nth root of y. So multiply siya og nth root of y both up and down, both numerator and the denominator. Muna pasabot sa kanang statement. By multiplying a radical both numerator and denominator, that will make the radicand on the denominator. Asa man ang radicand sa denominator? This one ang product niya. Ang resulting product wala siya gisuwat. But if you will if we are to discuss this one, this is ito multiply x times the nth root of y is x nth root of y. Tapad siya. But the nth root of y times the nth root of y, dapat yung result is the nth root of y square. Yeah, if n there as the index, nya 2 na siya, nya y square, so makancel ang exponent nga 2 ug index nga 2. So therefore magawas ang y. So katong pasabot nga that makes the radicand on the denominator a perfect nth power. So therefore a perfect square or a perfect cube siya. Magkuan dayon mag-extraction so that the denominator can be made into a rational one. Mugawas siya sa radical symbol, and that is y. Okay, so kanina siya nga concept, this is by default, no? Pwede niya siya ma-justify based sa example. Okay, we'll go to the example itself na yun. Let us study these examples to understand the rule given. The first example is square root of 2 over the square root of 7. So gibuwag na siya daan. So originally this is square root of 2 of the square root of 2 over 7, or is equal to the square root of 2 over the square root of 7. So rationalize by multiplying square root of 7 over square root of 7 to make the denominator a perfect square. Dili na siya and sorry. So square root of 2 over the square root of 7 times og square root of 7 over square root of 7. Kung sa denominator may multiply. Okay, para ang resulting product sa denominator is a perfect square. So 2 times 7 is square root of 14. And square root of 14 cannot be factored out anymore since it is irrational. Why? Kasi pinakaduol nga perfect square sa 14. 9 and 16. So therefore, kaning 14, maski imo na siya bungkagon, 2 times 7, 7 times 2. May line factors ang 14, kundi 7 times 2 raman. And none of the two factors is a perfect square. So therefore, it is irrational. Pabilin siyang square root of 14. While the root of 49 is 7, since it's a perfect square. The square root of 49 is 7. So this serves as our final answer, since our denominator is irrational number already. So, rational, tungkol kay whole number siya, or integer. Bahala radical ang numerator, basta ang denominator is not radical. Instead, rational, or whole number. Or in short, wa siya sus radical symbol. Sample 2. Square root of 5 over the square root of 3. Same with example number 1. Multiplyan o denominator ng square root of 3 over the square root of 3 as part of rationalization process. Next, 5 times 3 is 15. Again, 15 cannot be factored out since it is irrational. Pinakaduol ng perfect square niya is 16. So, dili pwede. Well, square root of 3 times square root of 3, square root of 9. And the square root of 9 is 3. So, the answer is square root of 15 over 3. Subtendra. Okay. Case number 2. Rationalizing the denominator when the denominator is a binomial. The principle used to remove such radical on the denominator is to multiply both numerator and denominator by the conjugate of the denominator. Ganina, monomial man to. So with this one, when our denominator is a binomial, so ang ato i-multiply is ang iyang conjugate. In symbols, this one. So the given expression is x by concept x, rational x over binomial nth root of y plus nth root of z is equal to the expression itself, x over nth root of y plus nth root of z times, kasi conjugate aning binomial is a binomial that has a opposite sign, which is minus, up and down. So kung sa denominator, may swat up and down, yung opposite sign. Then proceed to DPMA, distributive property multiplication over addition sa numerator. Kay monomial times binomial, o distribute x nth root of y minus x nth root of z. While ang product sa denominator, so ganina, if we will try to recall sa module number 7, multiplication of binomials that are conjugate to each other, we follow difference of two squares. The square of the first term minus the square of the second term, and the result is y minus z. To explain further sa kaning concept, I will have the example para dili ta maglibog. Okay? The first example given is square root of 2 over the square root of 5 plus square root of 3. So to rationalize, we multiply the conjugate of the denominator. So ang conjugate sa square root of 5 plus square root of 3 is square root of 5 minus square root of 3 up and down. Okay, next. Multiply the numerator using DPMA. Okay. Square root of 2 times square root of 5, square root of 10. Kaya ngano, number sa sulod times number sa sulod, number sa sulod. Square root of 2 times negative square root of 3, so minus 2 times 3, 6. And use DOTS, usap ng DOTS, difference of two squares on the denominator. And that follows the square of A, or the square of the first term minus the square of the second term. So the square of the first term, 5 times 5, 25. The square of the second term, 3 times 3, 9. Yeah, minus. So, square root of 25 minus square root of 9. Square root of 10 minus square root of 6. Maugi po siya magpabilin nga naman. We cannot subtract the numerator since they are dissimilar radicals. Anong dissimilar? They're not same. Okay. Do parehas lag index 2, imaginary 2, but ang ilang number sa sulod or ang radical mismo dili pareha. Ang usa 10, ang usa 6. So therefore, the numbers outside nga tag 1, 1, dili pwede masubtract. Then, what will happen? How about the denominator? The square root of 25 is 5. The square root of 9 is 3. So 5 minus 3 is 2. So this serves as our final answer since our denominator is rational number already. And that is 2. Example number 2. Given there is 2 over 3 minus square root of 7. By rationalization, we multiply the conjugate of the denominator na 3 minus square root of 7, and that is 3 plus square root of 7 over 3 plus square root of 7. Next, use DPMA, distributive property of multiplication over addition when multiplying duha ka numerator. 2 times 3, 6, plus 2 times square root of 7, 2 square root of 7. So, di na mahitabo ka nga 2 times square root of 7, square root of 14. Hindi na pwede kay. Ang 2 is rational. I-multiply nimo og number nga irrational, magtapad na sila. So, bisaya pa, number sa gawas times number sa gawas, which is imaginary 1. Munang 2 times 1, 2. And then, ang radical 7, kopyahon na siya kay kung mo siya kapares nga radical po nga tapad sa 2. Okay? And for the denominator, 3 minus square root of 7 times 3 plus square root of 7, we use difference of 2 squares. Munang square of the first term minus square of the second term. So the square of 3 is 9 minus the square of square root of 7, 7 times 7 is square root of 49. Next, numerator could not be added since it is dissimilar, no? Kay ang 6 rational. I-add nimo og 2 square root of 7, this is a combination of rational and irrational. So, wala may square root of 7 ang 6. So, dili pwede ma-add ang 6 og 2. So, never siya mahitabo nga 6 plus 2 square root of 7, mahimo siyang 8 square root of 7. Dili gina pwede. Okay? So, dili ta magbuot-buot. Then, the denominator, 9 man eh. This is already rational. So, we copy 9. So, di siya mahimo nga ang 9 mahimong 3. Kaya square root nimo ang 9. Dili pwede. So, 9 will remain as 9. Then, copy minus. Square root of 49 kana, mahimo siyang 7 because square root man just number. 49 is a perfect square. The root is 7. Munang 9 minus 7. Nasa 10. Okay. So, we copy the numerator since they cannot be added. 6 plus 2 square root of 7 over 2. Okay, 9 minus 7 is 2. So, that is our final answer for example number 2. Example 3. Given is 2 square root of 3 plus 3 square root of 2 over 3 square root of 2 minus 4 square root of 3. So, ang mga binomial of sa ubos ug taas na yung mga numbers sa gawas o na yung mga numbers sa sulod. Kompleto. So, how do we rationalize? We multiply the conjugate of the denominator sa expression nga 3 square root of 2 minus 4 square root of 3. So, siyang katbang 3 square root of 2 plus 4 square root of 3 up and down. So, 10. So, with this, since binomial times binomial naman ang numerator, we multiply the numerator using FOIL method. Namdam mo sa previous module. So, we'll use that one. So, balik ta. Numerator sa taha. So, F. First term. 2 square root of 3 times 3 square root of 2. So, number sa gawas, 2 times number sa sulod, 3, which is 6. Number sa sulod, 3 times number sa sulod, 2. 3 times 2, 6. Next, outer is a kilid. 2 square root of 3 times 4 square root of 3. So, 2 times 4 is 8. 3 times 3 is 9. Next, FOI, inner, is igtunga. 3 square root of 2 times 3 square root of 2. 3 times 3 sa gawas, 9. 2 times 2 sa sulod, 4. Then, FOI, last is L. Last term, ang puro second term sa kada binomial. 3 square root of 2 times 4 square root of 3. So, 3 times 4, 12. 2 times 3, 6. Sub 10. Okay. Later, ito simplify. How about the denominator? We use DOTS, difference of two squares on the denominator, the square of the first term minus square of the second term. So binomial times binomial niya conjugate, automatic to follow sa kaning DOTS, the square of the first term minus square sa second term. So square of the first term, so the square of 3 square root of 2. So 3 times 3, 9. 2 times 2, 4. Then copy, minus na sign. 4, the square of 4 square root of 3. 4 times 4, 16. 3 times 3, 9. Mag-shortcut na ni siya. Okay, we use this one, DOTS man. Next, 6 square root of 6. Iyang kapariha sa addition and subtraction of radicals, we add the numbers outside if they are of the same radical. Same index, same number sa sulod. So, ang kapariha sa 6 square root of 6 is ang 12 square root of 6. So, we add 6 and 12 sa gawas, which is 18. Copy radical 6. While the middle terms must simplify. Square root of 9 is 3. Multiply sa 8 na sa gawas. Square root of 4 is 2 times sa 9 sa gawas. While the denominator, the square root of 4 is 2 times 9 sa gawas. 9 times 2 minus. Square root of 9 is 3 times 16 sa gawas. 16 times 3. Okay na ba? So we add 6 square root of 6 or 12 square root of 6. Well, we multiply the root of 9 and 4 to its coefficient beside them. So, sa numerator, we copy 18 square root of 6. Dili na siya mausab. While 8 times 3 is 24. 9 times 2 is 18. So, 18 plus 24 is 42. Munang plus 42. Over denominator, sa man siya. 9 times 2 is 18. 16 times 3, 48. So, 18 minus 48 is negative 30. Next, we have this final answer. Nga naman siya, sir? So, nahitabo. Ang mga number sa gawas, like 18, 30, and 42, have common number nga makapa-reduce sa whole fraction. And their common number is 6. So, 18 can divide 6. 42 can divide 6. While 30 can divide 6. So, 18 divided by 6 is 3. 1 and 3 square root of 6. 42 divided by 6 is 7. Negative 30 divided by 6, negative 5. So, mo nang inana atong final answer. So far, nakasubay pa. Okay. Another way of dividing radicals is this one. The quotient of two radicals, the nth root of x over the nth root of y, is equal to the nth root of the quotient of two radicals. Tabi na kung parehas lang index. So the nth root of x over the nth root of y is just equal to the nth root of x over y. Reverse yan, no, ganina. So this one example para ma-justify ang atong concept. So the square root of 72 over the square root of 6, that is our given, can be written as the square root of 72 over 6. Nga naman, paros lang square root, no? Roy index. So 72 divided by 6 is 12. The square root of 12, ang iyahang simplified. And then ang square root of 12 can be factored out by 4 times 3, of which the square root of 4 is 2, pabilin ng 3. So that is our final answer. Number 2. Cube root of 10 over the cube root of 18. What happens? Praani, the cube root of 10 over 18. Ang pagsuwat niya, the cube root of 10 over 18. Yung 10 over 18 atong i-reduce. So may common sa 10 over 18. That is divisible by 2. So pila ka 2 sa 10? 5. Pila ka 2 sa 18? 9. So the simplified, it is helpful, no, nga, if possible, ma-reduce before mag-rationalize. So the cube root of 5 over the cube root of 9 ang iyahang simplified expression. Before pa ito mag-rationalize, we reduce the fraction by 2s before rationalizing it to make the denominator a perfect cube. Why perfect cube? Dapat perfect cube tungod kay atong ang atong index is 3. Nya atong denominator kay cube root of 9. So may pilay kuwang sa 9 para mahimo siyang perfect cube. So ito yung mga perfect cube. 1 cube is 1, 2 cube is 8, 3 cube is 27. So therefore, pila i-multiply sa 9 para ma-perfect cube? That is 3. Yeah, it should contain the same index, cube root of 3. Dapat ang index 3, pareho po sa index 3. So manang cube root of 3 over cube root of 3 siya. Kaya itong purpose ani, itong goal is para inig-multiply na to sa denominator, mahimo siyang perfect cube. And that is 9 times 3, 27. And the cube root of 27 is 3. So mo na mahitabo diri. So cube root of 5 times cube root of 3 is cube root of 15. Kaya 5 times 3, 15. Cube root of 9 times cube root of 3, 9 times 3 is 27. Wherein, 27 is a perfect cube. The cube root of 27 is 3. Munang 3 na lang ang nabilin sa denominator, while the numerator remains the same. Since 15 is not a perfect cube, nor a perfect square. So, that is our final answer. Third example. The square root of 42 a exponent 5 b cubed over square root of 6a cubed b exponent 4. Buwag sa itong isa. Pag combine mo into one radical, 42 divided by 6 ako nang i-divide it. So, may mo siyang 42 divided by 6? 7. Asa man dapat isot ang 7 nasa kasi denominator. At tugod siya sa numerator. Katungod kay whole number man. Whole number divided by whole number is a whole number. And that whole number should be written on the numerator. So 7 should be located on the numerator. While a exponent 5 over a exponent 3, itong over division, no? So when we divide powers of the same base, we subtract powers. Munang a exponent 5 minus 3. Ang gamay ng exponent, i-minus nga to sa dakong exponent. And that base should be written to where the exponent is bigger. Since ang exponent sa a kay mas dako man sa numerator, so dapat ang a makita sa numerator. Munang a exponent 5 minus 3. While sa b cubed over b exponent 4, since the exponent is bigger on the denominator, therefore the variable b or the base b should be written on the denominator. So 4 minus 3. Next, the simplified answer of this is 5 minus 3 is 2, munang a square. 4 minus 3 is 1, munang b na lang. Either you will write b exponent 1 or b is just the same. Then, diha pa ito mag-rationalize kay radical man ang denominator. Square root of b, kung bungkago na siya, this is 7, the square root of 7a square over the square root of b, no? So, we need to rationalize. We rationalize by multiplying it by square root of b over the square root of b. Kay b1 naman siya. So, kuwang siya og b1 para ma-b square, para ma-cancel sa index 2. Atong index is imaginary 2. So, therefore, 7, the square root of 7a square times square root of b is the square root of 7a square b. So, diagyapon siya. Then, b times b is b square. Okay? So, what's next? Is there square root of 7? Wala. Pero ang index is 2, imaginary 2. Makakancel siya sa exponent sa a which is 2. Muna mo gawas ang a. While ang b, dili pwede kay yung exponent 1. So nagpabilin ang 7 og b sulod sa radical symbol. While the denominator, our index is 2. Yung exponent sa b kay 2 man. So 2 divided by 2 is 1. Cancelled out. Magawas ang b sa radical symbol. Okay? So that serves as our final answer for example number 3. Another way of dividing radicals, especially when its indices are not the same, can be solved by this process. Division of radicals with different indices. It is important to remember that the product and quotient properties, it's very important to remember that the product and quotient properties for radicals can be used when radicals have the same index. When the indices differ, we do the following steps. First, we write the radicals into its exponential form. Mura po niyo siya ganina no, sa multiplication. When multiplying radicals of different indices. So magre-write the radicals into its exponential form, express their fractional exponents into similar fractions, subtract exponents by applying quotient rule, rewrite the exponential form back to its radical form, then simplify the radical expression. Okay. We will justify the following steps by our example. So to continue, we have this first example. The given is cube root of 2 divided by the fourth root of 2. So the first step is to rewrite the radicals into its exponential form. So the numerator is cube root of 2, so the exponential form is base 2 exponent 1 over 3. Ang 3 ang index. While the denominator is base 2 raised to exponent 1/4 because the index is 4, so the atong denominator is 4 said. If so to siya, dividing powers of the same base is subtracting their powers. Pareha mas lang base which is 2, therefore their powers or their exponents can be subtracted. Okay? Muna yung tabo dari. We copy the same base 2 and we subtract 1/4 nga to sa 1/3. Kaya kung ato na layson, mas dako ang 1/3 ka sa 1/4. So therefore, ang 1/4 i-minus nga to sa 1/3. Mo na ang base 2 kay numerator. Wala na yung denominator. Next, we cannot subtract directly 1/3 by 1/4. Why? Because they are unlike fractions. So we need to get first their least common denominator of 4 and 3, which is 12. Next is to get their common numerator. LCD is 12, so 12 divided by 3 is 4 times 1, 4. 12 divided by 4 is 3 times 1, 3. 4 minus 3 over 12 is 1 over 12. That is the exponent of 2. Then we need to rewrite the exponential form back to its radical form. So ang 2 exponent 1 over 12 can be written as index 12 radical symbol then 2. Since the exponent or the numerator is 1, so the exponent is 1, so pwede raw dili isuot ang exponent ng 1, no? When the least exponent is 1, we need not to write. So pwede raw siya basahon as 12th root of 2. And that is our final answer. Dili na siya usab kay wala may 12th root of 2. Second example. The square root of 2 over the 6th root of 32. First is to rewrite the radical into its exponential form. How? Square root of 2 can be written as 2. Base 2 raised to exponent 1/2. Anong 1/2? Kay ang exponent sa 2 kay 1, iyang index kay 2. 1 over 2 is equal to 2 exponent 1/2. How about the denominator? The 6th root of 32. So 32 raised to exponent 1 over 6. Okay, exponent sa 32 is 1 over index 6. Muna 1 over 6. Yan, 32 can be expressed as 2/5. Anong magagani? Anong i-sub siya? I-rewrite siya as 2/5? Pila din yan? 2/5. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2 is 32. So therefore, it is right. The jud nga, pwede usbon sa pagsuwat ang 32 as 2/5. Then we copy the exponent 1/6. Then next, we copy the numerator 2 exponent 1/2. Ang denominator na usab. Okay, duha man ni exponent 5 ug 1 6. So 5 times 1 6 is 5 6. 5 times 1 is 5 over denominator 6. Mo nang iyang denominator is written as base 2 exponent 5 over 6. Karon, same with this example number 1. Dividing powers of the same base is subtracting powers. Pareha man silang base 2. So masubtract na ang ilahang exponents nga 1 half og 5 over 6. Kasi mas dako ang 1 half or ang 5 over 6. Mas dako ang 5 over 6, no? So, regardless of kinsay dako nila, pwede magyapon nga ang dako nga fraction i-minus sa gamay nga fraction. So, it will follow this format. Since ang gamay nga fraction is nama sa numerator, mo na nga ang 2 is written as this one. Mahok siya numerator, wala siya denominator na. Even if kebawta nga ang 5 over 6 mas dako pa siya sa 1 half. Sige lang. We will follow this format lang. So base 2 exponent 1 half minus 5 over 6. Subtract the exponents. Di po di masubtract ang 1 half of 5 over 6 simply because they is parang denominator. They are unlike fractions. So magkotag LCD sa duha ka fraction nga 1 half of 5 over 6. Their common denominator is 6 man. So we copy base 2 exponent this one. So LCD sa 2 6 is 6. 6 divided by 2, first denominator is 3. 3 times 1, 3 na. 6 divided by 6, sa ikaduhang denominator 1. 1 times 5 is 5. 1 ang 3 minus 5, which is negative 2 over denominator 6. Now, kung imo siyang i-reduce, divisible by 2. So, that is negative 1/3. Ang exponent sa base 2. So, from this one until this one. Kaning part, when the exponent is negative, if we will go back to the laws of exponent, katong negative exponent rule, how are we going to make the negative exponent into a positive one? Katoning ruling nga x exponent negative n is equal to 1 over x exponent positive n. So therefore, kaning 2 exponent 1/3 munaog ni siya sa denominator. Ang numerator nato kay 1. Sakto? Using negative exponent rule, we can change the negative exponent to a positive 1 before rationalizing the denominator. Sakto. So as I've said, kaning 2 nga naay negative exponent, inaog siya sa denominator para ma-positive iyahang exponent nga 1/3. Mo nang 2 exponent positive 1/3 niya ang nasa numerator kay 1. Automatic na siya. Next is equal to 1 over. Okay, at this portion from exponential form to its radical form. Ang base nga 2 is what shows a radical symbol. Ang exponent niya kay 1, numerator. Iyahang index kay 3, mao ang denominator. So, 1 over the cube root of 2. Next is, ang atong denominator is radical man. So, what shall be done para ma-rationalize? Cube root pag yun. So, sa itong mga perfect cube, 1 cube is 1. 2 cube is 8. 2 times 2 times 2. So, pila i-multiply sa 2 para ma-8. Para ma-perfect cube siya ang gawas. It should be 4. It should contain the same index, no? Cube o cube. Yeah, cube root of 4, cube root of 4. Kung sa multiply sa denominator mo, sa multiply sa numerator. So, kay purpose, para ang denominator di-multiply, mahimo siyang 8. Cube root. Perfect cube is 8. So, next. So, 1 times cube root of 4. Yeah, cube root of 2 times cube root of 4 na. So the result is 1 times cube root of 4, cube root of 4. Cube root of 2 times cube root of 4, paros lang index 3. So 2 times 4 is 8. Yeah. The numerator remains the same. Okay, di man mausuwa may cube root sa 4, no? Okay, 4 is not a perfect cube. 4 is a perfect square. So we remain writing cube root of 4 sa numerator, while the cube root of 8 is 2. Kaya ba nga 8 is a perfect cube, which is 2 cube. 2 times 2 times 2. So, if atong i-rewrite ang 8 as 2 cube, makancel ang exponent nga 3 o index nga 3, unang gawas ang 2. Or, in other words, the cube root of 8 is 2 since 8 is a perfect cube. So, that serves as our final answer. So, for your activity, what's more, on page 7 of the module, you'll answer activity 8.1, items 1 to 5. Then what I can do on page 8, divide the following radicals in order to decode the question that is given, tunay boxes, and write the letter on the corresponding boxes with answers. So, dapat min solve ang katuto ng mga items para ma-decode ang trivia. Then post test. Answer items 1 to 10, letters only. You need not to write your solution para sa post test. The solution required is on what's more of what I can do. So thank you for listening. Hope this have helped you in understanding this module. For any inquiries and other questions, important questions, you can message me on our group chat or you can PM me on my Facebook. Once again, thank you and have a nice day.